And this is NASA Now, Lunar Reconnaissance Orbiter. What is it? What's it doing? And what can it tell us about the moon? And a stunning discovery found on the moon that could fuel rocket engines? That's ahead. But first, let's find out what else is happening at NASA Now. You might want to bring a filter if you plan on drinking water from the moon. Water ice recently discovered in dust at the bottom of a crater near the moon's south pole has mercury, magnesium, calcium, even a bit of silver in it. The discovery of water ice was surprising for scientists who had previously thought the lunar surface was barren and dry. The discovery was made by the Lunar Crater Observation and Sensing Satellite called LCROSS, a companion to NASA's Lunar Reconnaissance Orbiter. Now let's take a look at the past.
The Apollo 17 mission was the last manned mission to the moon. It landed on the moon on December 11, 1972. The Apollo 17 astronauts explored the moon using the lunar rover. They collected rock and soil samples and set up experiments there.
The Lunar Reconnaissance Orbiter, LRO, is currently collecting detailed information about the moon and its topography. And here to tell us more about it is Chief Scientist at NASA's Goddard Space Flight Center, Dr. James Garvin.
Well, I'm Jim Garvin. I'm the Chief Scientist at the Goddard Space Flight Center, and I also work as an Associate Project Scientist for the Lunar Reconnaissance Orbiter mission, which we call LRO. LRO is a very low-altitude robot spacecraft bristling with instruments that can measure the shape of the land on the moon. It can see what's in the ground, search for things that we might call resources that you could use if you were on the moon. We also have cameras that can see things the size of a beach ball on the surface. It's as if we're there. People often ask, so why would we want to go to this other world, no air, not a lot of water, trees, anything we like? The reason is that it's a window into our own past. The moon is like a time capsule that preserves what was happening throughout the solar system, particularly around the Earth, a long time ago. And those records have been totally wiped clean here on Earth. We've learned through LRO and other mechanisms that the moon does contain resources that could be invaluable as we learn to live and work in space. One could be small amounts of water frozen as ice in the lunar soils, which are as fine as talcum powder. We could convert it into things we need to live and work in space. Water is made of hydrogen and oxygen in a very magical molecule. We need it to live. And even as ice, we can use it. We can convert it, of course, from ice into gas. We can convert it into liquid. We can separate the hydrogen from the oxygen. Rockets run on those simple elements. We could actually produce rocket fuel. We could produce oxygen that we would need to breathe. So LRO has 9 experiments that allow us to build pieces of maps. It's kind of like a mosaic. Kind of cool. But the most critical to form the base map in which you lay everything on is an instrument known as LOLA, and it measures the relief of the ground, what's up and down, in 3D at very fine scale. Because if you want to go to the moon, land your spacecraft there, and there's no parking lots, landing strips, highways, you got to know where it's safe. This is what happened on Apollo 11 when Neil Armstrong was flying the Eagle in, and he looked down and said, oh, it looks too rough for me to land. So he flew several hundred meters further downrange before he landed. Mapping is something we take for granted. We drive our cars, GPS tells us where we're going. Maps are important, and they're a mathematical entity. Math is fun because it allows us to make maps that we can use as people and do cool things. So math underlies everything we do as we start to investigate the moon with LRO. So why do we want to map the moon? To get to know it, so we can design spacecraft for people and machines to go there. When we went to the moon back in the late 60s, early 70s, We went to 6 spots, worked hard for a couple days, mapped enough to know where to go, and we left it. We brought back samples, we did great stuff. There's a lot of the moon that's different, left to explore.
Did you know our first mapping of the moon began back in 1966? NASA's Lunar Orbiter program included 5 unmanned missions that mapped 99% of the moon using photography. Now you know.
Now it's your turn to collect information about craters on the moon so you can help find a safe landing zone for NASA's next moon mission.
The Lunar Reconnaissance Orbiter is gathering data on craters. Scientists believe that many of the craters on the moon were formed by the impact of meteorites. The size and appearance of a crater depend on 2 things: the size of the meteorite and its speed at impact. Now you can try and predict the effect of an object on the formation and appearance of a crater. Go to the virtual campus at explorerschools.nasa.gov for detailed instructions.
Well, that's it for NASA Now. Be sure to tune in next week when we learn about the special role NASA has in improving our air traffic control systems. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.